I don't know about you, but I've become a little bit obsessed with my immune system. So much so that I'm now taking 4 supplements a day, including something called French pine bark. It appears I will literally stuff bark in my mouth if there's a chance it will boost my immune cells.
Delicious!
I learned about the immune system when I was 16, but all I seem to have retained is white blood cell bacteria, nom nom nom. I've decided, given the current state of affairs, I should know a bit more. So, all aboard the COVID-19 Express. Let's learn about the immune system. Oh, sorry about that. Editing fail.
You're a coronavirus, Harry.
I'm a what?
A coronavirus.
Our very first line of defense is our skin. This is pretty effective at keeping out pathogens. Think the walls of Helm's Deep, with these guys as the pathogens. But things still need to come in, like oxygen, food, water, light, and penises. Come on, little fella, don't be shy. And things need to come out, like poo, wee, semen, and occasionally, babies. Okay, that's enough.
Release the hound.
To regulate what comes in, we have mucous membranes. These are like gates or portals determining what can enter and what can leave. Pathogens tend to attack us at these portals, so they've developed some brutal defenses. Goblet cells produce mucus that binds with pathogens, protecting our respiratory and digestive tracts. We have acid in our skin, stomach, and vaginas that destroy bacteria. Yes, that's right, our vaginas are full of acid. Lactic acid.
My eyes, the goggles do nothing.
Speaking of eyes, even they contain enzymes that destroy bacteria. The takeaway point is, we're pretty hard to get into. We evolved these defenses in an arms race with pathogens over millions of years. Your ancestors won their battle with infection long enough to pass on their genes whilst others died. Pretty savage. But occasionally, stuff gets in. And what's our first line of defense? The innate immune system. A breach has been made and pathogens are rushing in. First cells on the scene are phagocytes. Their name literally translates as eating cell, and eat they do. One type of phagocyte is a neutrophil. There's about 6 billion in a litre of human blood. They're covered in receptors to detect enemies, and they can move quickly to sites of infection. Once there, they have 3 attack methods. Phagocytosis, where they eat stuff, degranulation, where they spew toxic stuff, and they can spin a deadly protein web that binds, disarms, and actually kills pathogens. Neutrophils are so deadly, if activated, they've evolved to commit suicide after a day or two to protect your body cells. And what does millions of dead neutrophils look like? If you don't like videos of pus, look away now. Disgusting. Another type of phagocyte is the mighty macrophage. These huge cells can eat hundreds of bacteria before their digestive enzymes cause them to eat themselves. Once they meet an enemy, they can grab it with the tentacle thing and drag it in for consumption. It will then sound the alarm by sending out a bunch of messenger proteins called cytokines, alerting others to join the battle. But not all pathogens are easy to find. Some immune cells are master detectives. Natural killer cells. Yes, that's their actual name. These roam throughout the body looking for cells that have been infiltrated by a virus or cancer. But how can they tell? Every one of your cells with a nucleus is waving little protein flags called major histocompatibility complexes, or MHCs. These tell other cells about its health and status. So it's either totally fine, lol, or got a little cancer, sad face. Now, normally a white blood cell would detect the flags were dodgy and take action. But some viruses, like herpes, reduce the number of flags and infected cell waves, rendering it invisible to white blood cells. But not to the natural killer cell. If it recognizes a cell is displaying less flags than usual, it pumps out enzymes, ripping holes and triggering the target cell into apoptosis. The cell kills itself. When a cell gets infected by a virus, it generally releases a load of cytokines. Within these signaling molecules are a bunch called interferons, which tell other body cells that there's an intruder, so prepare for war. Your innate immune cells will then try to contain the enemy whilst waiting for backup to arrive. To make it easier for immune cells to access pathogens, mast cells release a cocktail of histamines and cytokines that dilate blood vessels, cause inflammation, and recruit more immune cells. Most of the time, our innate defenses are ferocious enough to deal with an attacker, but as COVID-19 has shown, sometimes it's not enough. Sometimes when the battle is lost, you must look to an unlikely hero to head off on a quest and save the day. Enter the Fellowship of the Dendritic Cells.